Let's do it. Hey, did you guys learn about standard position of angles last year?
No.
Oh, well, let me show you. When we're dealing with an XY axis, so we're going to take the origin as kind of the point or the vertex of our angle. And we're going to measure a 0-degree angle as having a position here at the positive x-axis. 0 is always going to be at the positive x-axis. And we're going to measure positive angles going counterclockwise. Back in geometry, you were probably told that negative angles don't make sense. But in trigonometry, they do. Negative angles go clockwise. So negative angles go clockwise, positive angles go counterclockwise. All right, so when we talk about angles and we talk about them in a particular position, and this is where we're getting into our unit circle, and you're going to want to start getting familiar with the positions of the different angles, both in degrees and in radians. So we're going to start by drawing an angle with a terminus. That just means it's kind of ending arm at 210 degrees. So I'm going to start here at 0, and that's a positive 210, so I need to rotate in this direction. And can you visualize where I would end after rotating 210 degrees? It's a little bit past a really important angle, a little bit past 180. So here's 180 plus another, how much? How much?
30.
Specifically 30, right? So it's 30 degrees past 180 degrees. This, it would be the location for our 210 degree angle. That would be the terminus of that angle. The line is, yes. So if I asked you to find the location of a 210 degree angle, you would draw that line. 0 degree angle, again, is at the positive x-axis. 210 would be here. All right. Now, that is not the only name for this line, 210 degrees, because we could have gone the other direction. We could have started here at 0 and gone this way instead. If we did that, we would be going in the negative direction. How far would we have had to go in this case? That's 90 plus another 60. That's 150. That's a negative 150 degree angle. Those both end at the same place. These are examples of coterminal angles. 210 degrees and negative 150 degrees will both get you to the same spot on our unit circle. Hey, you're fine. Woohoo! So 210, negative 150 get us to the same spot. But wait, there's more. There's some other angles that would also get us to that spot. What's another one? Think big. 570. 570, that would be all the way around. There's 360. Plus another 210. Yes, indeed, that would get us there, wouldn't it? So a 570 degree angle would also get us there. 570, that's 360 plus 210. Ooh, are you coming up with a big negative angle for me? Negative 510. Let's see if that works. If we go in the negative direction, we go all the way around. There's our negative 360 plus another 150. Yep, that does get us back to that same spot, doesn't it? So negative 360 plus 150 gets us to negative 510. And yeah, we could keep going and going and going. How would we keep going? If I wanted you to give me 10 angles that were all coterminal, what would you just keep doing? Just add and subtract multiples of 360, or if we're dealing in radians, 2 pi. So forget about the fancy radians for right now. Let's look at this 300-degree angle right here. This question is asking you to give me 2 positive and 2 negative coterminal angles. It's Friday and it's been a long week, so I will not judge you if you use your calculator here. Just take that 300 and start adding on some 360s to it. And get me a couple more positive versions. 300 plus 360, I might be able to pull that off without a calculator. That's 660, isn't it? 660 plus another 360 would be 1020. And if I wanted a couple negative coterminal angles, instead of adding 360, we could just back it up 360. So subtract 360 a couple times. 300 minus 360, that's negative 60. Minus another 360 would be negative 420. And there we go. And if we wanted to, we could keep adding and subtracting 360s all day and get as many of these as you wanted to. Now with radians, instead of adding and subtracting 360, we're going to add and subtract 2 pi's. But usually you're starting with something that's in terms of pi over 3 or pi over 6 or pi over 4. So sometimes it's useful to think of 2 pi in sort of a fancier way. 2 pi would equal what over 2? Would you agree that 4 pi over 2 is the same thing as 2 pi? If I wanted a fraction that was over 3 that was equal to 2 pi, what would I put on the top? 6 pi over 3 is the same as 2 pi. How about, what are some other versions of 2 pi that we could use? 8 pi over 4, 12 pi over 6. So dealing in radians, I think these are actually easier because the numbers are smaller. I'm going to take 5 pi over 3 and rotate a couple times around the circle. I'm going to add 2 pi, but I'm not going to think of it as 2 pi. I'm going to think of it as 6 pi over 3. 6 pi over 3 is 2 pi, right? Yeah, and you're right, it would be. 5 pi over 3 plus 6 pi over 3, that's 11 pi over 3. Plus another 6 pi over 3 would be 17 pi over 3. We could keep going if we wanted to. We don't need to. 23 pi over 3, 29 pi over 3, 35 pi over 3. Or we could back it up and go the other way and do minus 6 pi over 3. To get negative 1 pi over 3. Or negative 7 pi over 3. So I'm using 6 pi over 3 instead of 2 pi because it's more convenient. It's a like denominator, common denominator. So this will come up from time to time. You'll see it in your assignment. More commonly, though, you're going to use this to find friendly angles. Friendly angles are ones between 0 and 360. They're the ones we're used to thinking of. So if I ever give you a problem and it asks you to find, say, the cosine of 2,300, the first thing you're going to do is say, I don't really know what that looks like, but I can find a coterminal angle that is familiar to me by just subtracting a bunch of 360s from it. So you could divide by 360 and then figure out what your remainder is, and that would be your answer. Yeah, that works. I like that. Let me show you. This is my method. I type in my starting number, and then I hit minus 360, and then I just keep hitting enter until I get a number I like, because it'll just keep doing the same thing that you just did. Nope, too big, too big, too big. That'll do. It's 140. So if you start with the number that it gives you, and then just do hit enter, and then do minus 360, it'll just keep doing that over and over again. You don't have to keep typing it each time. For this, I'm going to do negative 37 over 6, and I'm going to be adding and subtracting 2 pi's. So for this one, kind of the same idea. I'm going to add this time. So I'm going to add 2 pi's. And I'll show you my kind of cheap way to do this in the calculator. I'm going to do negative 37 over 6, hit enter. Then I'm going to type plus 2 math frac. So I'm basically adding 2 instead of 2 pi. I'm leaving the pi's off. All right, negative 25 pi over 6, that's still too big. I want it positive. Nope. Oh, getting close. There we go. 11 pi over 6 gets us there. However you want to get there, there's different ways to do this. Yeah, I'd have to look at that. Now, there's something important going on here aside from like just adding and subtracting 360s, and this is going to be one of the big concepts. It's going to be a thread throughout this whole semester. Sine and cosine and tangent are things called periodic functions. You guys know what periodic means? Where else have you heard that? Periodic table of elements. And why is it called the periodic table of elements? No. Where else have you heard the word periodic before? How about at the library? What are periodicals? You guys you are not taught that anymore. Magazines and newspapers are periodicals. Those are things that are released on a regular basis, on a repetitive basis. The periodic table of elements is called the periodic table of elements because if you lined up all the elements from in numerical order, their properties repeat every so often. You take the repetition, you put them into rows, you get the periodic table of elements. Okay? That's why it's called it, because it's the repetition that is the reason for the periodic in the periodic table of elements. So these things are periodic because it doesn't matter whether I'm talking about the sine of 300 or the sine of 660 or the sine of 1020. Those values are all going to be the same. Sine repeats every 360 degrees. We're going to see that happen in a couple different ways. When we start graphing sine and cosine functions, we're going to see graphs that look like this. And there's a waveform that's a pattern that repeats itself every period or every revolution. We're going to solve equations with sines and cosines in them. And we're not going to get one answer. We're going to get an infinite number of answers because these things repeat their values every time you go around the circle. So more on that to come. This is kind of our first glimpse of that, though. All right, any questions about coterminal angles? All right, this next part is where we kind of get in the weeds a little bit. I need your full attention. I know it's Friday. I know there's a bug going around and we're all feeling a little miserable, but we got this. Okay, 2 key things that I need you to know about the unit circle. If you didn't pick this up last year, I need you to pick this up right here, right now. Cosine is related to the x-coordinate of points on the graph. Sine is related to the y-coordinate. Did you guys learn this last year? Okay, that's fine. I'm going to help you. I'm going to help you internalize it right now. Could you go ahead and draw me a circle on this x-y axis, please? The circle is centered at the origin. And make yourself a note with a little bit of space above here that our radius is equal to 1. I would love for you to find me the coordinates of these 4 points. These are called our quadrantiles. Quadrantiles. Quadrantiles are the points that are in between the quadrants. Find me x and y coordinates. I'll give you a hint. All of the x and y coordinates are going to be 0s and 1s and negative 1s. Spoiler alert, the first one is 1, 0. Because the radius is 1. Yep. Here we go. Now it's clicking. How about up here? 0, 1? Negative 1, 0? 0, negative 1. All right. And then somewhere off to the side, please write me another point that says cosine, comma, sine. Now, I don't want you writing this down because I didn't give you a whole lot of space, and I'm going to give you a whole big old wheel of fun later on that you'll have all this on. Just pay attention, though. What's my angle right here? 0. Can someone tell me what the cosine of 0 is? No, it's 1. What's this angle right here? 90 degrees. Can someone tell me what the cosine of 90 degrees is? It's 0. Can someone tell me what the cosine of 180 degrees is? It's negative 1. Can someone tell me what the cosine of 270 degrees is? It's 0. How about the sine of 0? 0. The sine of 90? The sine of 180? The sine of 270? Negative 1. Okay? Cosine goes with the x coordinate. Sine goes with the y coordinate. How many people have already learned this? Okay? You can try all those in your calculator if you want to. They absolutely work. Now, people then ask the question, what about tangent? Well, here's what I need you to know to get tangent. Tangent is sine over cosine. We're going to use that a lot. For right now, I just need you to know that if you divide the two things, you're going to get tangent. So what's the tangent of 0? What is sine divided by cosine? 0 divided by 1 is 0. This is interesting. What is the tangent of 90? What is 1 divided by 0? Undefined. There is no tangent of 90. There's vertical asymptote in the graph there. We'll see that later on. What is the tangent of 180? 0 divided by negative 1 is 0. Okay? Now, what I want to talk about right now is the signs in between these. So in between, we're going to have decimal values. Okay? And for right now, I just need you to be able to tell me whether sine and cosine are positive or negative in these regions. So in this region right here, this is the first quadrant. Is cosine going to be positive or negative? Now, are x coordinates in this region positive or negative? If x coordinates are positive, then cosine's positive, because x goes with cosine. And in this region right here, are the y coordinates positive or negative? So then sine would also be positive. What about in this region here? We're talking about points along our circle right here. So x coordinates in this region are negative. Cosine's negative in this quadrant. And sine would be, y coordinates would be positive in here. In this region, negative and negative. Everything's negative in this quadrant, isn't it? So cosine and sine would be negative. And in this region, the cosine is positive and the sine is negative. It's okay. There's notes in the back. All right, now we didn't talk about tangent, so let's talk about tangent in these quadrants. If I were to divide a positive divided by a positive, tangent is positive. Tangent in this quadrant is going to be positive over negative is negative. I heard just someone say a moment ago, what's tangent going to be in this quadrant? Negative divided by negative is positive, and negative here as well. All right, I'm going to give you the cheat code to this. You ready? Some of you have seen this. All students take calculus. All students take calculus. Have you learned this? When we get to our first test, A whole bunch of you are going to write this at the top of your test. I'm going to see that at the top of a lot of your homework pages too. This helps us remember which quadrants certain trig functions are positive in. They are all positive in this quadrant. Only sine is positive in this quadrant. The other two are negative. Tangent's the only one positive in this quadrant, and cosine's the only positive one in this quadrant. All right, so let's use this. Sine of 315. Eyeball me, where would 315 be on our xy axis? That's got a little squiggly there. Where is 315? 90, 180, 270, plus another 45. Be about right there in that quadrant. And this is sine. Sine goes with the x or the y? Sine goes with y, and this y coordinates are definitely negative in this quadrant. Would you agree that the sine of 315 is going to be a negative number? I'm not concerned with what the negative number is right now, just that it is a negative number. Next one, secant. I don't think in terms of secant, though, so what am I going to be thinking about? Cosine. I'm going to be thinking about the cosine. And I want to do 4 pi over 3. Can you picture where 4 pi over 3 is? It's a little bit bigger than 3 pi over 3. You're going to want to start thinking in terms of radians here. It's going to be in that quadrant there. Is cosine positive or negative in that quadrant? Negative? Okay, well, if cosine's negative, secant would be negative also. Secant and cosine will always be positive and negative together. Ooh, look at this one. Tangent of negative 100? Where's negative 100? Here's negative 90 plus another 10, so it's going to be in that third quadrant as well. Tangent's positive in that quadrant. Heck yeah. These last two are trick problems. Sine of 180. It's not positive, it's not negative, it's the thing in between. So it's not in a quadrant. 180 is on a quadrantal, so we have to think about our x and y coordinates. Remember, cosine goes with x, sine goes with y. How about tangent 3 pi over 2? Where's 3 pi over 2? 3 pi over 2 is right here. So I need to do sine over cosine. Well, sine is negative 1 and cosine is 0. Negative 1 over 0 is undefined. All right, this is going to be a little bit wobbly for you for a little while probably. We're going to firm it up all next week as we practice. Okay, for right now, I want us to be fairly confident with being able to know whether it's positive or negative in each of the quadrants. We're going to need that for what we're doing next. All right, folks, how are we doing? Great. Okay. Okay, we're moving on to your own paper now. We're going to do some problems out of the book. These problems are even-numbered problems in the same sections for what you're going to do in your assignment, which are all odd-numbered problems. So we'll do some examples that are just like the problems you're going to be doing for your assignment. You don't need to worry about your book. I'll write the problems up here. You're welcome to have it out, though. I'll tell you a page number as soon as I get to it here. It's 381. And we're going to start with number, what did I choose here? 4. So I'll put it up here, and you can go ahead and sketch it. We're doing number 4. Go ahead and sketch number 4 on your paper. By the way, it doesn't really matter those coordinates. You don't need to line it up on grid paper or anything. Just get it in the right quadrant. Excuse me. I took it away. There it is. And what they asked us to do is come up with the values of the 6 trig functions. So I'm just going to go ahead and set this up. Sine theta, cosine theta, tan theta. I'm going to line stuff up so that I got cosecant and sine next to each other. Cosine and secant. Now there's something really, really, really important that we didn't put into our notes, so we're going to put into this question right here, okay? It's the idea of a reference triangle. So I want to make sure everybody's got this down, and then I'll show you what a reference triangle is. A reference triangle is always going to be a right triangle. When we draw the position of an angle, that line is going to be our hypotenuse. And this is key. The reference triangle must always connect back to the x-axis. In this case, my reference triangle would look like this. Okay, it's a right triangle, and it connects back to the x-axis always. Never the y-axis, always the x-axis. Okay, make yourself a little note that this is called our reference triangle. And star connects to x-axis, triple underline. That's our reference triangle, and then this would be our reference angle. The reference angle is the angle in the reference triangle that's at the origin. We'll talk more about what reference angles do for us. They're going to make your job of memorizing sine, cosine, and tangent much easier. Because the thing is, the reference angle is always going to be an acute angle. It's always going to be less than 90 degrees. And it doesn't matter what your overall angle is. My angle here is somewhere between 270 and 360, but my reference angle will always be less than 90. And the sine, cosine, tangent of my reference angle will be the same as my sine, cosine, tangent for the other angle, except for positives and negatives. I'll show you what that means. Don't worry about internalizing all this. Just follow along with me. So first of all, let's go ahead and take care of positives and negatives for all these, because we got that covered, right? We know what quadrant we're in. It's the fourth quadrant, so help me out. And the fourth quadrant is sine positive or negative? Sine's negative. And cosine would be positive in this quadrant. Cosine's positive. Remember, cosine goes with x, and the x coordinates are positive in this quadrant. Tangents, sine over cosine, so negative over a positive is negative. Also, don't forget your little cheat code. All students take calculus. Which one's positive in this quadrant? C, cosine, right? So the rest are negative. By the way, sine is negative. That means that cosecant is also negative. Cosine and secant will always have the same sign, as will tangent and cotangent. So we've got all 6 of our signs. All we have to do is make some fractions, and we're done. All right, so we need some fraction bars here. We'll just stick some numbers in the top and the bottom, which means we're going to need some sides on our triangle. So, well, there's going to be a 4 and a 3. Which one's going to be 4? The x coordinate is 4, so in the x direction, this must be 4 units wide. The y coordinate is -3, so this must be 3. You could use Pythagorean theorem to find the hypotenuse, unless you happen to know that this is a special right triangle also. You guys know your 3, 4, 5 triangles? There's a 3, 4, 5 triangle. It's useful. It's not required to know. If you didn't know that that was 5, you would go 3 squared plus 4 squared equals x squared, and you would solve it. Pythagorean equation. 3 squared is 9, 16. Add them together, you get 25. 5 equals x. Or you could just memorize that anytime you see a triangle with 2 legs of 3 and 4, the hypotenuse is 5. The angles are not important angles. I kind of feel bad for them now saying them. All angles are important, but they're not ones that we're going to talk a lot about. I just made a judgment call on some angles. Yeah, they're decimals. All right, well, now we got those numbers. Fill in your fractions. Sine is, now here's your angle. Remember your angle's at the center always for the reference triangle. So from that angle, find me opposite and hypotenuse. From this angle, what would be your opposite over hypotenuse? It would be 3 over 5. There's my sine. Cosine is adjacent over hypotenuse. So find me adjacent and hypotenuse. 4 over 5. Tangent's opposite over adjacent. Those are nice. None of them turned out to be radicals. We know what to do if they do, though. And the rest of them are easy. Just flip them, right? 5 over 3, 5 over 4, 4 over 3, and we're done. All right, what questions do you have about that one? We doing all right? Okay, so you're going to end up doing 3 and 5. Now you are going to end up with some radicals because this isn't going to make a nice triangle like my last one did. In number 3, which of our 3 main trig functions are going to be positive for this quadrant? Sine, cosine, or tangent? All students, S, sine would be positive here, right? What about a number 5? Which one's going to be positive in number 5? Tangent, tangent, and go tangent. Yep. Hey, what turns different when we get down to 7, 8, or 7 through 11? Yeah, it's the same type of problem. The only difference is they didn't give you a picture. You're going to have to draw your own picture. Oh, no. Oh. You got it. You got this, guys. You can do it. You can do it. I believe in you. I believe in you. All right. I want to do 14 because the instructions are kind of weird looking. Let me just show you what this is going to look like. So let's do 14 together. The instructions are a little bit tough to follow, but when you see this example, you'll be like, this is no big deal. The information they give you is pi over 2 to pi. And they want you to know for angles between pi over 2 and pi, so this is a range of angles. They want to know are sine, cosine, and tangent positive or negative? That's it. Bless you. What quadrant are they giving us information about? They've kind of disguised it here. Pi over 2 and pi are here. So they're talking about this quadrant right here. So you tell me, which of our three are going to be positive in that quadrant? Just sine, right? And the rest are going to be negative? Sine's positive, these guys are negative. That's it. That's 14.
What if it gives us an angle that's not that like overlaps?
They won't. They're all quadrants.
What will we do when we encounter that in calculus?
You would be an ill-defined problem if it wasn't all the same. They would have to stick to one quadrant. Or they couldn't do all of them. Like I could ask you about sine from 0 to pi. Positive or negative? Is sine positive or negative from 0 to pi? Sine's positive for all of that. But if I'm doing all three quadrants, then I've got to narrow it down to 90 degree range. So, okay. Oh, this next one, you're going to love it. I don't think I got room on there. Flipping over. 32. Evaluate using a reference triangle. So you've done some problems like this, but all of the problems that you've done so far like this have been angles between 0 and 90. We're going to branch out and do some bigger angles this time. And I'm going to give you a step-by-step for this one. Seven pi over 3 is not a friendly angle. Oops, hang on. It's 13 pi over 4. Sorry, I was looking at the wrong problem. That's also not a friendly angle. What would be a friendlier angle that would be coterminal with 13 pi over 4? You could. I'd rather have you thinking in terms of radians. I could subtract 2 pi. Or instead of 2 pi, think of 8 pi over 4. Did you say 5 pi over 4? Yeah. Those are coterminal angles, so those would be the same. All right, so I'm going to walk you through step by step here. Step 1, draw your angle in position. You guys are going to be drawing so many XY axis and reference triangles in these next couple sections. Just get used to it. It's all right. 5 pi over 4 is, where is that? That's bigger than 4 pi over 4. How much is pi over 4? How many degrees is pi over 4? 45 degrees. All right, so 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Some of us are going to need a little bit of practice to get to that point where they can figure that out. You'll get there. Step 2. Positive or negative? We're doing the cotangent of an angle in the third quadrant. Is it going to be positive or negative? Cotangent is positive in that quadrant because tangent is positive in this quadrant, right? Awesome. All I need to do to finish this is to get myself a couple numbers put on the top and bottom of my fraction. Where do you suppose those are going to come from? Sides of a triangle. So step 3 is to draw a reference triangle. And your reference triangle always connects back to the... So you're not going to draw it like this, are you? No, that would be wrong. If you did that, that's okay. It's first day. Make that mistake now and never make it again. Always to the x-axis. Always, always. It's not always the same triangle. In this case, it is, yes. And the reference angle is going to be an important one. We want to know what that reference angle is, and I will usually get this in degrees. What is that angle going to be in degrees? It's a 45-degree angle. So reference triangle and reference angle is step 3. And if you know that that's a 45-degree angle and it's a right triangle, you got some numbers you can put in there, don't you? That's step 4. Label your sides. Now, when I give you a problem like this, it will be a 30, 60, 90 or a 45, 45, 90 problem. And now we have everything we need to complete the problem. All we're looking for is our ratio from our sides. This is cotangent, which is adjacent over opposite. From our reference angle, that would be 1 over 1. So final answer, positive 1. Questions on that one? 40 is the next one. Here we're going to skip 40 and we'll do our last one now. 46. It's a lot like this, but takes a little bit more sleuthing. See you guys. I'll post this here this afternoon. All right. This is word for word from the book. It says find sine theta and cosine theta. If cotangent theta is 3 over 7 and secant theta is less than 0. I'm going to give you some step-by-step for this too. Now the step-by-step for this is almost identical to step-by-step for what we just did. The big difference is we don't have an angle. We don't even know what quadrant it's in. But we got some facts about the quadrant. So that's going to be step 1, is use clues to pick a quadrant. Good. So for me, I'm getting 2 pieces of information out of this. One is that, and I always think in terms of sine, cosine, and tangent. Cotangent is positive. That means that tangent is positive. Agreed? Do you see how I knew that tangent was positive? Cotangent is positive 3 over 7. Agreed? So tangent must be positive. It's actually 7 over 3, but it's definitely positive. And secant is negative. That means that cosine is negative. Those two clues are enough for me to figure out what quadrant it's in. Where is tangent positive and cosine negative? That's quadrant 3. And then from there, just do what we did a second ago. So let's get your angle. So reference triangle. So quadrant 3 reference triangle. Keep in mind our overall goal was to find sine theta and cosine theta. I now know enough to tell you whether those two things are positive and negative. If we're in the third quadrant, tell me about the signs for sine and cosine. Both negative? Sine and cosine are both negative in this quadrant? Okay. Awesome. All I need is a ratio now. Where do you suppose we're going to get that ratio? From the triangle. Yep. Now, I don't have an angle, so it's not 30, 60, 90 or 45, 45, 90, but I do have a 3 and a 7 that I should be able to get onto some sides. Can you get those 3 and the 7 onto the right side? Cotangent is adjacent over opposite, so 3 and 7. Oh man, how am I going to get the hypotenuse? Oh, Pythagorean theorem. Yeah. Yeah. 7 squared plus 3 squared is x squared. 49 and 9. Yeah. I don't think that simplifies either, does it? Root 58. Nope. Cool. So, sine is just opposite over hypotenuse. Oh man, we're gonna have to rationalize. Wah, wah, wah. I'll tell you folks, if you can wrap your head around that example right there, if you can do a couple of these on your own in the assignment, then you are well on your way. Okay, this is probably this problem on, there are several problems like this on the test, and this is where most people struggled on the chapter 3 test last year. Okay, now my plan for Tuesday is to keep things short. I want to give you guys at least half a period to ask questions over the first 3 assignments. And to get questions, just general questions answered, because you guys were kind of on your own for the last 2 lessons. I am going to be giving you a new assignment on Tuesday, but I will not be checking the one that's on Canvas today. Okay, so try to do as much as you can, but if you can't do half of it because you're like, I don't know how to do this, it's okay. We got lots of time to answer questions Tuesday, and then I'll check that assignment on Thursday along with what I'm assigning on Tuesday. Question?
Do you have the sign for, over the weekend?
Do I know what it is? I can pull up Canvas. Any other questions for the greater good?